Hi guys, I'll be presenting you chapter 16, section 2.2. I'm Charles. The problem is, Jean Clark is the manager of Midtown Safeway grocery store, and she now needs to replenish her supply of strawberries. Her regular supplier can provide as many cases as she wants. However, because these strawberries already are very ripe, she will need to sell them tomorrow and then discard any that remain unsold. Jean estimates that she will be able to sell 12, 13, 14, or 15 cases tomorrow, and she can purchase the strawberries for $7 per case and sell them for $18 per case. Jean now needs to decide how many cases to purchase. Jean has checked the store's record on daily sales of strawberries. On this bias, she estimates that the prior probability are 0.1, 0.3, 0.4, and 0.2. And for being able to sell 12, 13, 14, and 15 cases of strawberries tomorrow. Question 8, develop a decision analyze formulation of this problem by identifying the decision alternatives, the state of nature, and the payoff table. And question B, how many cases of strawberries would Jane purchase if she uses the maximum payoff criterion? And question C, how many cases should be purchased according to the maximum likelihood criterion? Question D, how many cases should be purchased according to Bayes' decision rule? And question E, Jean thinks she has the prior probabilities just about right for selling 12 cases and selling 15 cases, but it's uncertain about how to split the prior probabilities for 13 cases and 14 cases. Reapply Bayes' decision rules when the prior probabilities of 13 and 14 cases are 0.2, 1, 0.2, and 0.5. Decision 2, 0.4 and 0.3, and decisions 3, 0.5 and 0.2. The matrix that we can construct. The state is how many values that we sell that day, and the decision variable is how many cases we buy. And here are the probabilities. And the value is calculated by using the 18 multiplied by number of sell cases and minus 3 multiplied by number of buy cases. And here's the Excel function. Using the maximum payoff criterion, we should first choose the minimum payoff for each decision alternative. According to the table, Jean should purchase 12 cases. For the maximum likelihood criterion, we find the maximum payoff of each alternative, then select the alternative which gives the maximum of these maximums. Hence, Jean would purchase 15 cases. And for the Bayes rule, the probability of each event that may occur, then we multiply by each value. We could observe that Jean will purchase 14 cases. For instance, to calculate the expected payoff for 10 cases, we use 0.1 to multiply by 132 and plus 0.3 multiply 132 and plus 0.4 multiply by 132 and plus 0.2 multiplied by 132. And the expected payoff for 11 cases is 0.1 multiplied by 125 plus 0.3 multiplied by 143 plus 0.4 multiplied by 143 and plus 0.2 multiplied by 143. And after comparing, we could find that the EP14 has the largest expected payoff. And we reapplied the Bayes decision rule when the prior probabilities of 13 and 14 are 0.2 and 0.5. From last problem, we obtained that buying 14 would be the optimal solution. In this problem, we have higher prior probability for 14 cases, so we could choose 14 cases without calculation. For this case, reapply the Bayes rules decision rule when the prior probability of 13 and 14 cases are 0.4 and 0.3. We use 0.1 multiplied by 125 and plus 0.4 multiplied by 143 plus 0.3 multiplied by 143 plus 0.2 multiplied by 143, which is 141.2. This is the case for buying 13. This is for buying 13 cases. And this one's for buying 14 cases, which we got 143.2. So we would choose to buy 14 cases. And for this one, we changed the probability to 0.5 and 0.2. And this one's for buying 13 cases, and this one's for buying 14 cases. We still observe that the expected payoff is larger than the expected payoff of buying 13 cases. So we will also choose 14 cases. And that's the end of the presentation, and thank you.